Let's talk about polygon interior angle measures. Our objective is to be able to find interior angle measures in polygons, specifically convex polygons. Let's start with what is a diagonal. We're going to do an exploration using the word diagonal. This is a segment joining two non-consecutive vertices. Non-consecutive means not next to each other. Consecutive means next to each other, so non-consecutive, not next to each other. Meaning, in this quadrilateral, if I start with one vertex, I can draw a diagonal not to here because this one is consecutive, and not to here because this one is consecutive, just to this other vertex across the quadrilateral. One diagonal. Now this exercise is asking us to draw the diagonals of each polygon below from one vertex only. Meaning, this is the only diagonal I can draw from that one vertex. I'm not going to draw any more from any other vertices. In this pentagon, I'm going to pick one vertex, such as here. I can draw a diagonal to this vertex, and I can draw a diagonal to this vertex. I cannot draw to this one because it's consecutive to the vertex I chose, and I cannot draw to this one because it's consecutive to the vertex I chose. So I can only draw two diagonals from that chosen vertex. In this hexagon, if I choose this vertex, I cannot draw it here. This is a diagonal, this is a diagonal, and this is a diagonal. In this heptagon, I'm going to choose this vertex, draw this diagonal, this diagonal, this diagonal, and I can draw one more diagonal. Now the next thing the directions ask me to do is to determine the number of triangles created in each polygon. Why triangles? Because we know a lot about triangles. So here we have two triangles. There are four sides to this polygon, and there are two triangles that we can make by drawing a diagonal. Now remember that we're trying to think about the interior angle measures of the polygon. So if we think about the angles in the triangle, like this angle, and this angle, remember that we know in a triangle, the interior angles always add up to 180 degrees. Similarly, this is a triangle, so we know this angle plus this angle plus this angle also add up to 180 degrees. Notice I'm using different types of angle marks because I don't want you to think that I'm saying these angles are congruent. They may or may not be. I don't have that information. So these angles are all touching the vertices of the polygon. If these interior angles add up to 180 and these interior angles add up to 180, that's going to tell me how much all of the interior angles add up to if I add up all of those angles. So I've got two 180s. I can do 2 times 180, and that makes 360 degrees. In the quadrilateral, the interior angles add up to 360 degrees. How many triangles do I have in the pentagon, where I have 5 sides and 5 angles? Here's a triangle. Those angles will add up to 180 degrees. Here's another triangle, and here's a third triangle. This time I have 3 triangles. So if I want to find out how much the pentagon's interior angles add up to, that would be 3 times 180. That would be 540 degrees. The interior angles of the pentagon add up to 540 degrees. How many triangles in the hexagon, where there are 6 sides and 6 angles? 1, 2, 3, 4. 4 triangles, which means I would do 4 times 180 degrees. That would give me 720 degrees. Finally, the 7-sided polygon, which is our heptagon, 1, 2, 3, 4, 5. 5 triangles, which means to find out the number that the interior angles measure add up to 5 times 180, which is 900 degrees. Now notice that the interior angle measures don't always add up to the same thing. The more sides we get, the more the angle measures will add up to. Notice a pattern also. The number of sides to get to the number of triangles, which is the number that we multiply by 180, that's a 4, it went down to 2. That's a 5, it went down to 3. That's a 6, it went down to 4. That's a 7, it went down to 5. How much does it go down by each time? That's right, it goes down by 2. So if I say that n equals the number of sides, or the number of angles, then n minus 2 would equal the number of triangles that I can make from drawing diagonals from one vertex. Therefore, the sum of the measures of the interior angles of a convex polygon is always the number of sides minus 2. Do that first, then multiply by 180 degrees. This is called our Polygon interior angle theorem. This is for the sum of the measures of the interior angles. Only for convex polygons. Those are ones we are going to deal with. This is a really important formula that we are going to use a lot and memorize and remember always. Let's see how we can apply it. For example, solve for x. Notice that these are inside the polygon. Now, really, they should have degree symbols like this one does. All of these expressions should have that to help us know that these are angle measures. But the fact that they're in the corner where the angles are also tells me that these are for angle measures. So because these are angles, and because these angles are interior, we know that the sum of these angles has to be the number of sides minus 2 times 180 degrees. Now the number of sides we know is the same as the number of angles. So I can count 1, 2, 3, 4, 5, 6. There are 6 angles, therefore 6 sides. So I'm going to find the sum by doing 6 minus 2. I do that first and then multiply by 180. 6 minus 2 is 4, and 4 times 180 makes 720. So these angle measures add up to 720 degrees. That's what they add up to. So I'm going to take each one and add them up. 5x minus 6. Next, 4x plus 14. Now there are a lot, so I'm going to mark them as I go. 7x, 8x minus 8. Notice I'm lining up the like terms. 6x, and finally 120. 120 goes in the column where there are no x's. Draw a line, a plus sign. Adding these up makes 30x plus 120, and that has to equal 720. Now we can solve that equation. My equation is 30x plus 120 equals 720. I start by subtracting 120 from both sides. I get 30x by itself, that equals 600. Then dividing by 30 leaves me with x equal to 20. Make sure I've done everything it's asked in the directions. Solve for x. Yes, I have. Cool. Let's look at another example. The sum of the measures of the interior angles of a convex polygon is given. Classify, remember classify means to name, the polygon by the number of sides. Now as soon as I see sum and interior, I'm going to remember my formula, n minus 2 times 180. Now they already gave me the sum. The sum is 1440. So this is equal to that sum, 1440. I need to solve for the number of sides, which is n in my equation. So let's solve this equation. I want to get the n by itself, and this expression is multiplied to 180. So the inverse operation of that is divide by 180. That gives me the n minus 2 all by itself, which now I don't need parentheses because there's nothing next to the n minus 2, and 1440 divided by 180 makes 8. Next, I add 2 to both sides. Adding 2 to both sides leaves me with n equal to 10. There are 10 sides, and to classify the polygon means I'll name it. 10 sides is a decagon. Cool. Finally, find the measure of the sum of the interior angles of the indicated regular convex polygon. So again, as soon as I see sum and interior, I think n minus 2 times 180 degrees. Now let's see what they gave me. We're working with a regular nonagon. Nonagon, non sounds like 9. That's exactly what it is. That means n is 9. The number of sides or angles is 9. So I can plug that in here. 9 minus 2 times 180. I do the 9 minus 2 first. 7 times 180. And that gives me 1,260. So the sum of the interior angles measures 1,260 degrees. Now I want to know how much is one interior angle, which, because it's regular, means that all of the angles are congruent. And when all of the angles, that's an angle symbol, are congruent, I divide the sum by how many angles there are. 1,260 divided by 9 makes 140. So there are the measures of one interior angle, 140 degrees. Thanks for watching.